Hello everyone and welcome back to my channel Be Yourself. This is Dr. Rajni and today I am with the topic of active sites of enzyme and models of the enzyme activity. So I already have discussed about I have given a small introduction about the enzyme, how enzyme commission act to classify the enzymes. Now this time I am with the active site of the enzyme. So let's begin. Now first I will explain you what are the exactly model for the enzymes. So it is well known to all of you that the lock and key model, which was proposed by Emil Fischer in 1894 was the first model which has tried to explain the enzyme substrate reaction. So as per this model, as just like the lock, there exists a specific nature of the key structure which you have, which we put under the inside the lock, is quite unique in nature. Just like that, the enzyme and substrate reaction will also be there, and a lock can only be opened if the key is right. If it is not right, it will not open. If it will not complementary to the internal structure of the lock, it will not be able to open the lock. But if it is complementary, then we will able to open the keys, which says that exactly it is with the enzyme and substrate. If enzyme structure, active site of the enzyme is exactly complementary to that of the substrate, then the product will form, or it will decrease the activation energy in the process of formation of the product. But actually this was not well accepted. If I say that enzyme is binding to the substrate just complementary to each other, it means there is a very less amount of struggle between the enzyme and the substrate. So during this process, very less amount of energy and this structure will be quite stable. And if the structure is stable, it means to dissociate the substrate to form the product will be difficult. So this was not well accepted, and later on it was said that it is not exactly the same. Rather, instead of the lock and key model, there suppose this is the enzyme and this is the substrate, this is the enzyme and this is the substrate. But you know that during the formation of any reaction, or during any reactions, there exists a transition state. So suppose A has reacted with the B, and in the intermediate state it has formed into B as a transition state, and then it finally changed into B plus C. In this case, what will happen? This reaction is quite fast reaction, and the rate of formation of AB, if this reaction and this transition state is not as stable as that of this and this structure. So what will be happening here? As soon as this will be for this AB transition state will form, what it will try, in order to stabilize itself, it will try to reverse its direction and it will again reform into A plus B. So to explain this, I have just shown you with the help of animation. So suppose that enzyme is exactly complementary to that of the substrate, then what will happen? And this is the structure of the transition state. Now as there is exact complementary between the enzyme and substrate, then what will happen? In order to go in the transition state, substrate do not have any space and it will try to enter into the transition state, but it will not be able to enter, and finally the product formation will be hampered, or the rate of the product formation will be hampered. So finally in 1930, and Halden was the scientist who has proposed that enzyme should be complementary to the transition state, not to the substrate, and this statement was well explained by Linus Pauling in 1946. And finally the most accepted model of the enzyme substrate reaction come into existence, which was proposed by Daniel Kostland in 1958. As per this model, what happens? The enzyme contain an active site which is not the complementary with the substrate. Rather, when substrate comes and bind to the enzyme change itself, or allosteric structure of the enzyme will be changed, and then at this stage it will become the complementary to that of the substrate. And what it do during this process, two things will be done. Number one, in the number one process, what will be done, when you know that thermodynamically, when any structure is being formed or when any bonding will be formed between two structure, then there is a release of some energy. So during this process it will be releasing some amount of energy which will assist to lower the activation energy of the reaction. Next thing what it will do, it will do the collision, it will favor the collision theory. And as per the collision theory, what it is there, if we have to make a reaction successful, then what we need, the reaction, the substrate should be colliding with the, or the two substrates should collide in such a way that their reactive side should be facing each other. So this will expose the substrate, two substrate together in such a way that they can react properly. So here what the function of enzyme, what the function of active site is actually, it is during the formation of enzyme substrate association, it will release certain amount of energy, and this energy will assist to lower the activation energy. Second thing is that it will favor the collision theory, and as per this theory it will expose the active site of the substrate together facing each other, so that proper collision of the molecule will take place and reaction can proceed. Apart from this active site, there exists another site, and this site basically inhibitors bind to the enzyme, and when inhibitor will bind to the site, then what will happen, it will again create a allosteric change in the allosteric conformation of the enzyme. And due to this process, the active site which need to change itself, which need to arrange its amino acid so that it can hold substrate, will not be done. At this time what will happen, the function of enzyme will be inhibited and substrate will not be able to bind with the enzyme. Now what we have known is known till now, that lock and key model is not the efficient one. Second thing is that the induced fit model, how it is inducing, it is inducing at the proper site, at a particular site of the enzyme which is known as the active site, and along with the active site of enzyme it also contains the allosteric site which will be bonded by the which can be bonded by the other substance, which will cause the molecular changes or the structural changes in the enzyme and prevent its binding to the substrate. This is the diagram which I have taken from the Leininger. I just explain it in very clearly, that whatever we have studied till now. So suppose this is a reaction, and in the absence of reaction, or just suppose it as a as it is been written metal stick, but you suppose it as a wooden stick. So if I will ask you to break the wooden stick, what you will do, you will bend the wooden stick to break it. So if you will not bend it, the product will not be formed. Similarly, when the enzyme will be complementary to the substrate, it will not get the space to get bent, and this structure is quite stable. As you can see here, enzyme substrate reaction is quite stable and negative energy is well established. So why, the reason is that whenever any compound is formed, it is formed to gain the minimum energy to get it stabilized. So if it is already stable, then why it will be changed into the product? So because in this process, because of this, in this process the activation energy will not be lowered, rather it will remain the same. Whereas in the last case, where the enzyme active site is complementary to that of the transition state, here you can see enzyme substrate has been formed together, but in the transition state, during this when it is going up to the transition state, it is requiring very less amount of energy, and this release of energy is decreasing the activation energy of the enzyme substrate reactions, and finally the product is being formed. Now, the question arises, what exactly the bonding is there which is decreasing the activation energy, and how it can be catalyzing, how it is stabilizing the transition state. So, three catalytic activity of the enzyme is here. One is the general acid base catalysis, covalent catalysis, and metal ion catalysis. So, let's see how it functions. So, first come to the general acid base catalysis. Let's take a reaction. Suppose this is the reactant 1 and this is the reactant 2. Both when they will react together, they will be changed into the product. Now, how the reaction it will take place here? Oxygen being more reactive, these two reactants, in this two reactant, what will happen? And it will first undergo a transition state. So during this process, what will happen here? First, because of the more electronegativity of the oxygen, electron will be pulled toward the oxygen, and to compensate it, it will ask electron from the OH group of the nearby reactant, and after that what will form? The intermediate will be formed. And as here the density of electron is more, so it will be having the partial negative charge, and here partial positive charge will be created. Now, what is here? What is the fact is here, the structure, this reactant structure, when they are away from each other, these structures are more stable. So what will happen? In order to stabilize the transition state, what will happen? The reverse reaction will be favored. So what will be the role of catalysis? It will prevent it to go for the reverse reaction. So what we can do here, if I will stabilize this positive and negative charge, then it may be possible that it will not go in the reverse reaction. So usually what happens? The reaction takes place inside the aqueous media. So to stabilize this, what will happen? This hydrogen ion, to remove this plus charge, the hydrogen ion will be removed, and this will combine with the water molecule to form the hydronium ion, or H3O plus. But if enzyme will not be present here, then what is the requirement to carry out the reaction in absence of enzyme? The rate of formation of H3 plus should be very high, so that as soon as the hydrogen ion, as soon as this transition state will come, it will be converted into the hydronium ion. It is just like that. If I say there is a competition that you not how much time, or if I will say there is a tank where water is been coming inside, and there is a challenge that the challenge is that you have to draw water out of this tank in such a manner that no overflow of water should be there. So what you will do? It is possible only when you will draw the water with the rate greater than it is filling up the tank. So similarly, if you want to continue the reaction in absence of the enzyme, then the rate of formation of hydronium ion should be high as compared to that it is going to the reverse direction. Understood? But if it is not so, then we need an enzyme, and that enzyme will be having the active site which will be controlling, or which will be consuming this hydrogen as much in a very fast manner, so that the reverse reaction will not be proceeded. Rather, in the presence of enzyme, what will happen? Their forward reaction will be favored, and finally we will able to gain our product. Got it? Similarly, in the second case, in the covalent catalytic reaction, suppose take any reaction A and B in presence of the aqueous medium, where it has to break down into A plus B. So here what will happen? In presence of enzyme, what it will be done, that an intermediate state will be formed which will prevent it to rebind with the B, and it will favor the forward reaction, where in the aqueous media this enzyme will prevent the A and B reassociation, and finally we will get the product A plus B. Now finally the last one, metal ion catalysis. So you all know that metal ion catalysis, metals are used, or metals are required to make the enzyme a active form, or to provide the activity of the enzyme. and sometimes it is also termed as the cofactor for the enzyme. So metals can be present inside the enzyme just like that of the prosthetic group, or it may be associated temporarily at the time of the reaction when the reaction need to initiate, and it may be possible that substrate itself may be containing the metals ions which will be assisting enzyme in the form of cofactor. Another thing is that metal also, or the ionic interaction, as it is a metal, it will be containing either the positive charge or the 2 plus charge, as it if it will be belonging to the alkali metal, it will be containing the plus charge, and if it will be belonging to the alkali earth metal, it will be carrying the plus 2 charges. And when this metal is charged, then what will happen, it will form an ionic interaction with the enzyme substrate intermediate, and it will also help the orientation of the substrate, or it will also help to stabilize the substrate or enzyme substrate in the transition state so that the forward reaction can take place. Another way how metal can act as a catalysis, it will induce the oxidation reduction reactions, and it will prevent the reverse flow of the reaction. So these were all how the enzyme were acting at the active site, and this is all following the induced fit model of the enzyme reaction. In the next class, we will be discussing about the mechanism of action of enzymes with respect to the free energy changes, how del G is responsible, how in the transition state energy will be released, which will be minimizing the activation energy. So these were all for the today. Hope you liked the video, and if there is any comment, don't forget to comment on the comment section so that I can also improve if there you need some change in the teaching style also, because learning never ends. If I can learn from you, then I will be very happy for that. So don't forget to subscribe and share my channel. Till then, have a nice day.